Hi, in this video we're going to look at the topic of binomial expansion. This is a core 2 topic for most of the syllabuses, but I think MEI do it at core 1. I'm going to assume that you're doing it at core 2 and show you how we're going to do this using a calculator for some of the steps. So if you want a non-calculator paper, this video probably won't be a huge amount of help for you, but for everybody else, hopefully it should be. As ever, if you want more information, you can follow me on Twitter at Mr_G_Walton or the school account at Tupton Maths. Okay, let's have a look at this topic in detail then. So what we're going to be able to do in this video is, by the end of it, we're going to have expanded some brackets where the power is greater than 2. So at GCSE, you will have expanded some quadratic brackets, maybe something in the form of, I don't know, x plus 3 all squared. And you'll remember that that is the same as doing x plus 3 multiplied by x plus 3. And it's not just simply multiplying x by itself, so squaring x, and adding on 3 squared. Okay, so this is kind of key in terms of what we're going to be doing here. We can't just square x and square through. We've got to set it out in a way like this at GCSE, and for when we're doing things with powers greater than 2, I'll show you how to do it using the binomial expansion. That means that we're going to get some terms in the middle. Now, by that, if I just expand out this pair here, you'll see that we get x squared plus a 3x and another 3x over here, so 6x plus 9. Now if I just multiplied it out, x squared and 3 squared, and I've got this term and this term, but I wouldn't have got the one in the middle. Okay, this is going to be important again for when we're doing binomial expansion. What we're also going to be able to do is find the coefficient of specific terms in an expansion. So if this is quite a large power, you can see that we might end up with lots of different terms. At this point, we had 2 terms here, and we ended up getting, it was squared here with 2 terms. We ended up getting 3 terms. As this power increases, we get more and more terms because we get x to the power whatever it is, and then x to the power of 1 less than that, and 1 less again, and so on and so on and so on. Okay, so we're going to be able to find specific coefficients of individual terms. And at the end, we're going to look at answering some exam style questions as well. Okay, let's make a start and let's have a look at this first example. The question says, using the binomial expansion, or otherwise, express 1 plus x all to the power 4 in ascending powers of x. Okay, first thing we need to do is make sure we read the question carefully. It's asking for ascending, so going up. So powers going up this time. Right, how I'm going to do this, I'm just going to set it out in the way that I always set these out, and then I'll explain where these things come from. And with some of the terminology that I'm using, you might not be too familiar with. But just to start with, don't worry too much. What I'm going to do is start writing this out in a pattern. I've noticed that it's power 4. So first of all, I'm going to write this. 4c0. Do not worry at this stage what that is. It will become perfectly clear when I've explained. So we've got 4c0. We're going to multiply it by the number that we have at the beginning of my bracket, so 1. So multiplied by 1 to the power of 4, that's the power that I've got up here, and I also want to multiply this by x to the power of 0. And what I'm going to do is make sure that when I'm doing all of these different terms, I'm always going to make sure that this power and this power, if I add them together, it will equal the power that I'm looking at in the question, so 4. So this is going to be my first term. My next term is going to be, so plus 4c1 multiplied by 1 to the power of 3, x to the power of 1. Notice the pattern that's gone on here. My c number has gone up by 1. The first term here has gone down by 1 in terms of its power, and the x term has gone from 0 up to 1. Okay, let's do the next one. 4c2, 1 to the power of 2, x to the power of 2, plus 4c3, x to the power of 1, 1 to the power of 1, x to the power of 3, plus 4c4, 1 to the power of 0, x to the power of 4. Now, let's see if we can work out where these things come from. This idea of 4c0, this part at the front of my binomial expansion is going to give me a value. Now you can just type that in on your calculator if you like. You can just find it, it'll be an NCR button. So you're looking for a button that says NCR on your calculator. And if you type in 4C0, on my calculator it looks a little bit like this. 4C0, it'll give you an answer of 1. Why? Okay, let's see if we can see where these values are coming from. They come from something called Pascal's triangle. Now Pascal's triangle looks a little bit like this. Okay, and what happens is the number below two numbers added together forms this value. So here we can see the first kind of row is just 1, and then we have a pair of 1s. Now these pair of 1s add together to make 2, and we have 1s either side. 1 and 2 makes 3, 1 and 2 makes 3, 1 and 3 makes 4, 3 and 3 makes 6, 3 and 1 make 4, and 1 at the end again. So these are the first few rows of Pascal's triangle. Now it goes on like this forever. Now you might say, well, where are these values coming from? Well, this in Pascal's triangle is called row 0. This is row 1, row 2, row 3, row 4, and so on and so on and so on. Now, I could write down Pascal's triangle each time to get the values that I'm going to put here. However, it's much easier when the numbers are big to use my calculator, because these values from Pascal's triangle are all stored in your calculator under this C notation. So the first row is actually 0, C, 0. The next two values along here is 1, C0 and 1, C1. The next values along are 2C0, 2C1, so 2C0, 2C1, 2C2. Okay, so this value relates to this one in the second row, this value relates to this on the second row, and this relates to this value on the second row. These numbers are just stored in your calculator ready for you to use, and Pascal's triangle has all kinds of different uses. You'll see it if you do statistics as well, when you're doing combinations. But for now, I don't want you to worry too much about it. Just follow the process and you will get the right answers. Okay, so let's carry on now. I'm just going to tidy this up. So I'm just going to move my screen up slightly. Okay, just to here, and then we'll tidy these values up. Now the first term that we're looking at is this one, 4C0. Well, 4C0 on my calculator just gives me 1. So what I've got is 1 multiplied by 1 to the power of 4, which is 1, multiplied by x to the power of 0, which is 1. So my first term is going to be 1. My next term is 4C1. Now, if we're looking on our Pascal's triangle, we can see that this is the next value along here. It's this one. Okay, so the row that I'm interested in here is 4 because it's the power of 4. So the next one along, or typed in your calculator 4C1, will give you the value of 4. So I've got 4 multiplied by 1 cubed, which is 1, multiplied by x to the power of 1. So that's x. So I've got 4x. The next value along, 4c2, you type it in your calculator, you will see that you get 6. So my next value is 6 multiplied by 1 squared, which is 1, multiplied by x squared. So my next value is 6x squared. Then the next term is 4c3, which on my calculator is 4. Looking on Pascal's triangle again, we can see it's 4 here. So we've got 4 multiplied by 1 to the power of 1, which is just 1, multiplied by x cubed. So plus 4x cubed. And the very last term, I can see that I've got 4c4, which is 1, multiplied by 1 to the power of 0, 1, multiplied by x to the 4, so my final value is x to the power of 4. Okay, let's tidy my x up a little bit. So we've got x to the power of 4, and these are my terms. So if I'm looking at expanding the numbers in the question, which was 1 plus x, all to the power of 4, these are the terms that I'm going to get. 1 plus 4x plus 6x squared plus 4x cubed plus x to the 4. Now, in this case, the 1 didn't really do very much. The x didn't really do very much either. But we're going to see more examples of how these coefficients at the front may end up changing because we don't have a 1 in the bracket. So we might not have anything that looks like 1 plus x to the power n. This 1 here could be a different value. And if that's a different value, you can see how the binomial coefficients are going to change. That's because we're going to have different values in these brackets here. Okay, all raised to different powers. And if this is not just x, but it might be 2x or x divided by 3 or minus x, then you can see that these terms again might change and we might get different signs here instead of all being positive. Okay, so stick with this, follow the same procedure as we've done here, and I'll lead you through the next one. Okay, so in this one we can see the expression 1 minus 1 over x squared all to the power 3 can be written in this form. 1 plus p over x squared plus q over x to the 4 minus 1 over x to the 6. Find the values of the integers p and q. Okay, well, I'm going to set it out in exactly the same way that I set out the last one. Okay, here we go then. So we're thinking about the power. You can see the power is 3. So we're going to start off with 3c0, 1 to the power of 3. Now notice this part. This is really important. Everything that is part of the x term, so I've got a minus 1 over x squared, I'm now going to put in my bracket here. So minus 1 over x squared all to the power of 0. Okay, plus 3c1 multiplied by 1 squared multiplied by minus 1 over x squared to the power of 1. Notice again that I'm making these two numbers add up to this one. My 1, the power for my 1 term goes down by 1 each time. The power of my x term goes up by 1 each time. Plus 3c2, 1 to the power of 1 minus 1 over x squared all to the power 2, plus my final term 3c3, 1 to the power of 0 minus 1 over x squared cubed. Okay, let's tidy each of these terms up then. So the first term, we can see that we've got 3c0. Again, on your calculator if you want to, you can do this. Alternatively, if you just want to write down Pascal's triangle, I'll do it up here. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. This is my third row. So we can see that the values I'm going to get for 3C0 is going to be 1, 3C1, 3, 3C2, 3, and 3C3, 1. Okay, so let's tidy this up like I say. So we've got 1 multiplied by 1 cubed, which is 1, multiplied by minus 1 over x squared all to the power of 0 is just 1 again. So my first term is 1. Next, 3C1 is 3. So I've now got 3 multiplied by 1 squared, which is 1, multiplied by minus 1 over x squared, all to the power of 1. Fine. Next term. Oh, shall I tidy this up as I go? Let's do that. So here we've got 3 multiplied by, I got carried away here. So we've got 3 multiplied by this term here. So it's minus 3 over x squared. Remember, if I'm multiplying something here, I've got a value here of 3, I'm multiplying it by this fraction in effect. This is a bit like 3 over 1, if you want to think of it like that. So when I'm multiplying, I multiply my top part, multiply my bottom part, and I'll end up with minus 3 over x squared. Okay, let's move on to the next bit, the next term, which is this one now. So I've got 3C2, which is 3. So plus 3 lots of 1 to the power of 1, which is 1, minus 1 over x squared squared. Right, let's tidy this bit up then. So again, we've got 3 times 1, which is 3, 1 over minus x squared all squared. So this is timesing it by itself now. So what we've got is 1 squared, if you'd like me to do this over here. So we've got 1 squared and we've got minus x squared squared. So we've got 1 over x to the 4. So this part becomes 1 over x to the 4, but I'm multiplying by 3. So 3 over x to the 4. Notice what I've done this in one step, but of course you can tidy this up in one extra go if you want to. You can multiply this little bit out and write it down again. I'm just doing it in one go, but you can feel free to do whichever way you like. Last term is we've got plus 3C3, which is 1, multiplied by 1 to the power of 0, which is 1, multiplied by this horrible looking thing now. So minus 1 over x cubed, minus x squared, all cubed. Right, remember now, if I've got a negative something, whatever it is, and I'm cubing it, a negative times a negative is positive, multiplied by negative again will give me a negative value. So this is going to be minus. Also remember what happens here. 1 over x squared, all cubed, is minus 1 over x to the 6. So minus 1 over x to the 6. Okay, just make my 6 look a little bit more like a 6. Right, now let's just see if this kind of holds up with what the question was asking for. At this point, I've done the work. I'm now checking to see. So the question says it should be in the form of 1 plus p over x squared. Ooh, I've got a minus. Okay, let's not worry too much. Let's think about it in a minute. Plus q over x to the 4. So I've got something over x to the 4 minus 1 over x to the 6. Okay, so this looks pretty good. What we need to think about are what the values of the integers p and q could be to make this look like this. Well, p here is positive p. I've got a negative value here, so I can comfortably say that P is minus 3. Let's look at the next term for Q. Q is it's plus Q, mine's a plus, this is 3, so Q is positive 3. So here are my values for P and Q. Okay, again, notice that when I worked my way through this, I set it out in exactly the same way as I did in example 1. I had my coefficient here using Pascal's triangle. I then had the first value in brackets with the biggest power going down each time. I then had the x part. In this case, I know it looks nasty because I've got a minus and a fraction, but I wasn't too concerned. I put that in brackets and started increasing the powers going up. Then tidying it up and getting it in a nice simplified form at the end. Right, here's a third example then. This time, this is a bit more of a difficult question. This is something that you're going to be asked to do in a longer-winded exam-style question. We've got the first part here, the expression 1 minus 2x to the 4 can be written in this form by using a binomial expansion. Otherwise, find the values of P and Q, very similar to the last example. Then it says find the coefficient of x in this expansion, 2 plus x to the 9. Okay, well we don't have to do the whole thing. We're just going to find the coefficient of x, and that's okay. And then finally, find the coefficient of x in the expansion when we're multiplying these two things together. So we're going to have to think quite carefully about how we can get an x term from this multiplied by whatever it is that I get from here. Okay, let's work our way through this then. If at this point you feel really comfortable expanding this part out, pause the video. I'm going to go through it and then you can see if you get the same values for P and Q that I do. If not, carry on watching. Okay, so I'm going to set it out in exactly the same way as I did all the other ones. I'm looking at my power first. I notice it's power 4, so I'm going to start off and we're going to go 4C0 1 to the power 4 minus 2x to the 0 plus 4C1 1 cubed multiplied by minus 2x to the power 1 plus 4C2 1 squared minus 2x to the power 2 plus 4C3 1 to the power of, where are we up to, 4, 3, 2, 1, minus 2x, I'm going to run out of space, minus 2x to the power of 3, plus 4C4, 1 to the power of 0, minus 2x to the power of 4. And then I'm going to tidy it up. So my first term is 1 times 1 multiplied by 1 multiplied by 1. Easy, 1. Next one, 4C1 is 4 multiplied by 1 multiplied by minus 2x. Tidy this bit up and I don't get plus there, I get minus 8x. Next term, 4C2 is 6. Again, if you want to get these values from your calculator, that's fine, or using Pascal's triangle. Either way, 4C2 is still 6. Multiplied by 1, multiplied by minus 2x all squared. This is going to be, so minus 2x all squared is 4x squared. Multiplied by 6 is 24x squared. Okay, don't forget when you're doing this part and you're squaring it, you're going to also remember to square the minus 2. That's why I put it all in brackets. Okay, next term, 4C3 is 4. So plus 4 multiplied by 1 multiplied by minus 2x cubed. Minus 2x cubed. Minus 2x cubed is going to be minus 8x cubed. So minus 8 multiplied by 4 is minus 32. And the last term is 1, so plus 1 multiplied by 1 multiplied by minus 2x all to the 4. Minus 2 to the power of 4 is, well, 2 times 2 is 4, times 2 again is 8, times 2 again is 16. This is a negative value, and it's to an even power, so it's positive. So we've got 16x to the 4. So plus 16x to the 4. Right, let's check to see what values I have now for P and Q. P is minus 8, Q is 24. Okay, good. That's fairly straightforward, the first part. Let's see if we can now move on to part B. So I'm just going to slide my screen up and we'll work on part B. Okay. Now, part B says find the coefficient of x in the expansion of 2 plus x to the 9. But I'm only interested in the bit where I'm going to get an x from. So if we're looking at our values that we've just been doing, let's just see which one gave us an x term. Well, the x term came from here. So let's think about what happened to get to that point. Now, if you feel more comfortable starting at the beginning, that's fine, and I'll probably do the same with you now. But if you want to carry on and go straight for the second term, if you like, you can do. So let's think. It started with power 9. So my very first term, which actually I'm not interested in because that's not going to give me any x's, but we'll do it for completeness, will be 9c0 multiplied by 2 to the power 9 multiplied by x to the power 0. Right, the term that I'm particularly interested in then is this one. 9c1 multiplied by 2 to the power 8 multiplied by x to the power 1. Well, 9c1 is 9 multiplied by 2 to the power of 8. I'm not sure what that is off the top of my head, so I can do that on my calculator. And we get 256. So 256x. So if I carry on tidying this up, I've got now 9 times 256, which again on my calculator is 2304. So the coefficient of x in the expansion, that is 2304. Right, now the final part then, it says find the coefficient of x in the expansion of these two things multiplied together. Now, we don't need to multiply all this out. We're going to get a load of terms we're not interested in. The only term that I'm particularly interested in is the coefficient of x. That's the only bit it's asked for. Now, let's think about how we can get an x term. Well, I could get an x if I have a single value multiplied by an x, or an x multiplied by a single value. And by that, let's start identifying which ones of these are going to give us the individual parts then. Let's see. I could get an x by multiplying 1 from this first part of the question. Remember, this is my 1 minus 2x to the power 4, all expanded out. If I did 1 multiplied by this, then I've got one of my terms. I've got 2304x. But that's not the only place I can get an x from. I can also get an x from if I had this minus 8x here, and I multiplied it by the value that I get from this part of my expansion that I said I didn't need previously. This is just going to give me a number, remember. 9c0 is 1, 2 to the power of 9 is going to be 512. If you're not sure, just check on your calculator, but that's going to give me 512. So I've also got the case when I've got minus 8x multiplied by 512. That's going to give me another value, which I'll write over here, of minus 4096x. So if I started to collect my like terms together now, the place that I can get an x from, let's just double check that I'm doing this right. So I've got my 1 multiplied by where I can get an x. I've got my x term multiplied by a value. Anything else that I times together, an x times an x is going to get me an x squared, or an x squared multiplied by a value, or anything. All these other terms, when they're multiplied, are going to give me powers greater than just x to the power of 1. So I'm happy that these two things are right. Let's collect my two like terms together then and see what I get. And these add together to give me minus 1792x. So find the coefficient of x in this expansion, minus 1792. Okay. It's time for you to have a go by yourself now. I've tried to combine a couple of these skills in a particular exam question. You can see this is worth 8 marks. So it's going to take you a little while to do. I'll give yourself maybe 10 minutes or so on this. If it takes you a little bit longer for now, that's fine because you're learning how to do it. But over time, we should aim really for about a minute a mark, in which case somewhere between 8 and 10 minutes would be ideal for this sort of a question. Anyway, pause the video, have a go, and I will show you the solutions in a minute. Okay, let's see how we've got on there. So I'm going to start expanding out. It says we want the first 4 terms, and it noticing that it's the power of 7. So first of all, I've got 7c0, 1 to the power 7, 2x to the power 0, plus 7c1, 1 to the power 6, 2x to the power 1, plus 7c2, 1 to the power of 5, 2x squared, plus 7c3, 1 to the power of 4, 2x cubed. Let's just see if that's enough terms. 1, 2, 3, 4 terms. Okay, so let's tidy this up then. 7c1, this first part is just going to give me 1. Next part is I've got 7 multiplied by 2x, which is 14x. Next part, 7c2 is 21 multiplied by, so this part's 21, multiplied by 1, it's still 21, multiplied by 2x all squared, so that's 4x squared. 21 times 4 is 84. So plus 84x squared. And then the last part, 7c3. And then the final term where I've got 7c3 multiplied by 1 to the 4 is going to be 7c3 is 35 multiplied by 2 cubed, which is 8, and 8 35s are 280. And again, you could set this out a little bit with a few more steps, but for now, that's fine. Okay, so the values of A, B, and C. A equals 14, B equals 84, C equals 280. Don't omit this step. Just because you've done all the hard maths doesn't mean say that you've answered the questions, the actual question. It says find the values of the integers A, B, and C. So actually state what they are. Right, the next part says, hence find the coefficient of x cubed. So this is the bit I'm interested in, x cubed. In the expansion, 1 minus a half x squared multiplied by the bit that we've just done. Okay, so let's multiply out 1 minus a half x squared first. We don't need to use binomial expansion for this, it's just a simple GCSE style expansion. So let's do that. So I've got 1 minus a half x multiplied by 1 minus a half x. That's going to give me 1. My outside pair is minus a half x, and my inside pair is another minus a half x. So I've got minus x, and then minus a half x times minus a half x is plus a quarter x squared. Now, thinking about where I can get an x cubed from then. Well, I can get an x cubed if I multiply this by an x cubed. I would get x cubed. If I multiply this by some sort of x squared term, I'd get an x squared. And if I multiply this by an x, I would get the right term there too. So then the final part, we can actually start looking at the coefficients that I've got already. So if we're dealing with this first part, we've got 1 multiplied by 280 x cubed, which is going to give me 280 x cubed. Then I've got minus x, so minus whatever my x squared term is here, so minus 84. So I've got, let's write it down, minus 1 multiplied by, in fact it's not minus 1, it's minus x. Let's do this properly. I've got minus x multiplied by 84 x squared, which is minus 84 x cubed, and the final part is I have a quarter x squared multiplied by 14x, which is going to give me 14 over 4x cubed, and I can now add up all of these values to get my final coefficient. And I'm going to do that on my calculator, which works out at 199.5. So 199.5 x cubed. Okay, if you got these values, really well done. This is not an easy exam question. As you can see, there's 8 marks here and it will take you a little while to work your way through. But hopefully you've seen, by working at a sensible kind of way and sticking to a pattern, no matter what the sorts of questions are going to throw at us, we'll always set it out in exactly the same way. Okay, and this should hold you in good stead for when you're doing your exams. So if you've been making any revision card notes, what I would say when we're doing this is stick to a formal written method with some sort of pattern to minimise the errors. We all make mistakes, but the key to this is to try and get as few mistakes as possible. And by having a method, a pattern that you can follow, that's going to help you. It's also useful to remember where these values are coming from. So Pascal's triangle is useful, but it's not important if you're happy just to use your calculator. You can just work out the NCR button on there. So NCR button, and that'll tell you the individual terms. If you are using Pascal's triangle, remember that the first row with just a 1 on by itself is the 0 row. That's something that can sometimes confuse people. This is my first row, and so on. If you've got anything other than just an x, stick it in a bracket. So any negative coefficients of x, put in a bracket. If you've got numbers there as well, remember to put those in. And when you've got something in a bracket, you might have something like minus 3x all squared. Remember that it's not just minus 3x squared. You've got to square this part too. So this would become 9x squared. These are common mistakes too. Okay, hopefully this has been a useful video. If you need any further help, then ask your classroom teacher, or alternatively, ask me on Twitter. I'm also going to put a link underneath this on YouTube to a worksheet and some worked examples where you can practice this topic. Okay, good luck in any exams. See you soon. Bye.